Hello and welcome. Some of the biggest transformation that's happening in industrial processes happens at a point where it meets the Internet of Things, and that's where things get really interesting. To find out more and learn more about what's happening to a particularly large company in this space, Emerson, I'm joined by its president, Edward L. Monser, who's also the vice chair of the US-India Strategic Partnership. Thank you so much for joining us.
Great, thank you.
Mr. Monser.
Happy to be here.
So tell us, what are the key trends that you're seeing in the industrial automation, industrial engineering to the artificial intelligence, add-on and digital world today?
Yeah, well, we're at a very exciting part in the progression, and it has been a progression. Things have gone step by step in many ways, but we're now at the point where we can do closed loop, optimized solution for a full plant versus a subsystem. Now, all of the things that we've been working on have been scalable, which means we could start with small pieces and build upon those successes over the years. But now we're to the point where we can do full simulations, dynamic simulations of full operating plants, like a power plant, to have it run and be in control, but have the same data feed a simulator or a digital twin to allow the operators and the engineers to find a better level of performance for that plant in the simulator, and then apply it to the real world through the control system.
And that's already happening?
That's happening now.
Right.
And 40% of the power plants in the United States now have that capability. A much higher percentage of that of the new plants in China now have that capability, and we're trying to get that applied globally because of the ability to dramatically improve the safety, reliability, and performance of the plants.
Right. So can you give us one illustration of what that means when you, as you said, you port back the learnings from the digital twin to the physical world? What could the operator do differently, and what could that plant deliver differently?
Yeah, well, there's 2 or 3 ways. The first way is the simulation, you can then run the clock forward at a faster speed. So you can see 1 month, 2 months, 3 months in the future. And from the trends and the data and the analytics that are present, you can tell if something's going to cause a disruption. Right. And then you can take the action to avoid the disruption. So the elimination of unplanned downtime is hugely beneficial. In a power plant, a lot of things have been done to clean up the power plant's operation with supercritical, ultra supercritical kind of processes, but you lose all of that if there's a disruption in the process. The most unsafe time, the most environmentally disruptive time is when there's an unplanned shutdown. In the shutdown and the startup, you can wipe out all of your statistics for a year. So to be able to see in the future, see where there's a weakness in the system, deal with it, correct it, you can eliminate unplanned downtime.
Right. And this is where artificial intelligence is playing a role?
The artificial intelligence is what enables you to do the analysis, to see that. But really, we're only starting to use the artificial intelligence tools. Other analytics and algorithms are telling us a lot, but the ability to have a plant communicating with the grid and the grid communicating back to the plant to tell it what to do to make the overall grid work better, that's when I think artificial intelligence will really have a payoff. We're just now at the point where it's going to be a multi-plant kind of infrastructure in the simulation, and then artificial intelligence applied to it. But you know, there's hundreds and hundreds of thousands of sensors feeding data on a millisecond basis that's the data input to these machines. Very rich environment for higher levels of performance. The thing that's most exciting to me is we're not just making incremental improvement right now. We're improving by 10%, 20%, 30%, 50% in many operations. The tools have proven that the dream of 10 years ago was right. And so it's fun to see it applied.
Right. So slightly lateral question, how much of this learning or knowledge are you able to apply in the renewable energy space, or essentially the renewable energy space?
Well, it would apply to In terms of the basic model, which is sensors generating data, feeding analytics, and then the analytics feeding the optimization machines, that applies in a lot of different spaces. Our business at Emerson, we're focused on non-renewable.
Yes.
Because that's the prevailing tool for generating energy on the planet. And so we're trying to do that in the most efficient, conscientious, and best way so that every natural resource is properly used. But it would apply to wind or solar,
well, yeah.
the same kind of optimization and predictive diagnostics to tell when things are going to happen would be helpful. The biggest issue with renewables, as you know, is it's not steady state. And so it's very disruptive to the grid. And predictive diagnostics would certainly help show when there's going to be a disruption or when there's going to be a slowdown, and that could lessen the impact on the grid. We don't do that work, but it would definitely apply.
Right. So let me ask you a couple of India questions. You're obviously present here on ground and have been for many years, and you're a frequent visitor as well. What are the changes you're seeing in the context of, let's say, the newer technologies that are coming in? Where do you see India contributing in that equation?
Well, on the technology side, our major investment here is in global engineering. So we've got a number of global engineering centers focused on big problems around safety, environment, and efficient use of resources. And those engineering centers have thousands of engineers doing that work to solve a problem that can be applied anywhere. That's not new, but the scale of what we're doing is new and continues. The other thing that we're doing in India is adding to that global engineering a much stronger footprint for regional manufacturing, so that we manufacture in India for India, but more importantly, India for the region, which to us means India exporting to the Middle East, India exporting to Africa, India exporting to Southeast Asia. So a major regional play in manufacturing, and that's driving a number of investments for us right now.
And that's something new compared to your traditional strategy?
Right. Our traditional strategy would have been India for India. That's what we do in the US, United States for the United States, Russia for Russia, China for China. But in India, we've seen some very special capability to be competitive in a broader region. And so we're using India to scale across that full area. Because of the engineering backbone we have, it allows us to solve problems in those areas. We also now see we can effectively and competitively manufacture in India for that full region.
Right. And you're also going to be expanding capacity or at least setting up more
yeah, right now we have 17 factories in India, but we're in the process of building the largest factory that we'll have, and in the most modern and the most automated, and that's going to go into Chakan. I was just in Mumbai at the Magnetic Maharashtra kickoff yesterday because of that major investment, and able to talk and update the officials there on the progress. We're now moving the dirt to build the factory, but in a 2-year time we'll have 1,600 employees building valves for the process industry to be distributed throughout that full region.
Right. And you're also on the vice chair of the USIndia Strategic Initiative. Tell us about what are the issues that you're focusing on there now and will do in the year ahead.
The Strategic Partnership Forum it's a new group formed last year.
Yeah. It was like a breakaway of the USIBC.
Yeah, it was a leaving of the US-India Business Council. The full executive board moved and the full board of directors moved over into a new group because we really wanted to do a more aggressive focus on the economic development that can be done between India and the United States. And that's grown, but not at the pace that we think is possible. So we wanted a more focused and aggressive way of doing it. So we formed an independent group for that dialogue. We think today there's $130 billion of shared economic activity between the US and India. We think that number today could be 500 billion. Now in the future even more than that. but the actions that are necessary and the initiatives on both sides. A good example of that would be a company like Mahindra is investing heavily in the United States. Well, what is needed for Mahindra to be successful in the plants that they're building in the U.S. to serve in the U.S. market? And the reciprocal then for companies that are from the U.S. investing in India. What are the things needed for them to be successful, accepted, and prosper in India? We also work with both governments on what's necessary for the U.S. and India to be globally competitive. The tax program in the U.S., of course, big deal. Make in India, the ease of doing business in India, a very big deal here. And fortunately, we're seeing progress on both fronts. But those are the kinds of discussions and meetings that we have on a continuous basis. And the progress has been good. The Prime Minister here, Prime Minister Modi, we think has done a very good job from a business perspective of saying we're going to make it easier for businesses to be successful. That will drive economic improvement for all of the citizens of India. To me, it looks like it's working.
Right. And one last question. So your key, again, this is a global question. What are the key 2 or 3 things that you're looking at as opportunities and challenges for the year ahead, for the next year?
You know, the biggest challenge, and you know, this is something that I know will be solved, but it is a concern, is the workforce needed to apply the new technology so broadly, and we moved from the laboratory to a broad application, is not ready. The number that PwC used here at the conference was 90 million new jobs using this technology. How are they going to get ready? When are they going to get ready? The opportunity is there, so I know people will put the energy into it, but there's a lot of work that's needed to prepare people to get full advantage of the new technology.
Right, Mr. Monser, thank you so much for speaking with us.
You bet.
Thank you.
Thank you.